This micro-credential deals with access control lists and consists of 5 targeted skills. This targeted skill is about the basics of access control lists. Access control lists, ACLs, are an essential component of computer networking and security. They are used to manage and control access to network resources by defining a set of rules that determine which packets are allowed to pass through a network device, such as a router or firewall, and which are denied. At its core, an ACL is a sequential list of rules that define the conditions under which packets are permitted or denied. Each rule consists of 2 parts, a matching criteria and an action to be taken. The matching criteria can include various parameters, such as source and destination internet protocol, port numbers, and other packet attributes. ACLs are typically applied at network device interfaces, such as inbound or outbound interfaces of a router. When a packet enters or exits an interface, it is checked against the ACL rules in sequential order until a match is found. The action associated with the matching rule is then applied to the packet, either allowing or denying its passage. ACLs are commonly used for different purposes, including network security, traffic filtering, and quality of service (QoS) management. Some examples of how ACLs can be utilized are: 1. Network security. ACLs can be used to enforce security policies by permitting or denying specific traffic based on defined criteria. For instance, an organization might configure an ACL to block incoming traffic from certain IP addresses or restrict access to sensitive resources. It may also be used to block IP addresses from certain countries where network attacks have originated. 2. Traffic filtering. ACLs enable network administrators to control the flow of traffic by allowing or denying specific protocols, ports, or IP addresses. This helps in optimizing network performance and preventing unauthorized access to network services. For example, blocking port 3389 on the firewall will not allow anyone to remote desktop protocol, RDP, into a workstation on the internal network. 3. Quality of service, QoS management. ACLs can be utilized to prioritize or rate limit network traffic. By assigning different priorities or bandwidth limits to specific packets, organizations can ensure that critical applications receive the necessary resources and avoid congestion issues. It is important to be sure that there is enough bandwidth for Voice over Internet Protocol, VoIP, applications when large amounts of data are being transferred. ACLs can be implemented using either standard or extended ACLs. Standard ACLs primarily consider the source IP address and their matching criteria. However, extended ACLs offer greater flexibility by incorporating additional parameters, such as destination IP address, port numbers, and protocols. When configuring ACLs, it is crucial to consider their order and placement. ACLs are processed sequentially, so the order of rules matters. Typically, the most specific rule should be placed at the top, followed by more general rules at the bottom. This ensures that packets are matched against the appropriate rules and prevents unintended consequences. Furthermore, ACLs can be either stateless or stateful. Stateless ACLs evaluate each packet individually without considering the context of previous packets. In contrast, stateful ACLs maintain information about the state of network connections and can make decisions based on the packet's relationship to the overall flow of traffic. Stateful ACLs are often used in scenarios where more advanced filtering and security requirements exist. Finally, remember that access control lists, ACLs, are a fundamental tool for managing network access and traffic. They allow organizations to enforce security policies, filter traffic based on various criteria, and optimize network performance. By defining rules and actions, ACLs provide granular, fine control over network communication and play a vital role in securing and regulating network resources.